Hi, welcome back to the channel. This is Victoria, and today we're going to be taking a look at the anatomy of a C# for Revit code. We have in front of us the Visual Studio coding environment, and I'm going to be explaining the different aspects of this code. For those of you who don't know, Revit was built on the back of a .NET framework, which is why C# is the preferred language for working in Revit. However, you can make plugins for Revit using Python. There are many videos on YouTube that teach you how to do that. But for today, we're going to be taking a look at the C# interface. In subsequent videos, I'll be breaking down the actual process for creating these elements step by step. But for those of you who have already started to delve into coding, but you're a bit intimidated by the C# environment, I thought that I could explain what makes up a C# for Revit plugin in terms of the anatomy of the code, and possibly that helps you feel less intimidated and you can get cracking on C#. First of all, C# is very similar to Python. Actually, all programming languages are quite similar. The main differences are in the syntax and in the rules for writing syntax. Once you're able to understand the syntax for C#, it's kind of the same logic as any other coding language. I will say that C# is a bit more verbose in terms of the fact that Python is streamlined. When you're calling variables, you kind of just make a variable and you don't have to declare it first. In C#, you do have to declare everything before you create it. But like I said, in subsequent videos, we'll delve into detail of how to actually write C# code. In this video, I just want to explain what the anatomy of a C# for Revit code looks like. So let's dive in. First of all, let's look at the Visual Studio interface. You have your regular menu and you have your easy debug tools. And over here, this is what would be equivalent to a Revit project browser. This is your file explorer. Now, the key things you need over here are these two references. And you also need to create a class, which is where your actual code for the plugin will be stored. And you need an add-in manifest file. So let's look at the add-in manifest file and also the class to explain what makes it up and how it works in Revit. Firstly, you have to declare all your references. When you have Revit API and Revit API UI, as your references, you'll be able to access the backend of the Revit API, which is the Revit database, the Revit UI, and the Revit attributes. Without these two references, you would find that you're not able to call on these two libraries as they would provide errors in your code. That's why it's important to start here. Now, a key setting for the Revit API and Revit API UI is to make sure that copy local is set to false. And what this means is every time you compile your code, you don't want to copy the entire Revit API library. It's going to create a duplicate on your computer and possibly cause problems. So you have to make sure that copy local is false. Once you have that set for both references, then you're good to go. So next up, what is the namespace? In C#, the namespace is how you would separate different groups of classes. The class that we're looking at today is the collect windows class, but I can have several classes that do several functions in Revit. I can have one that collects doors. I can have one that changes parameters. Now, I wouldn't create a new project reference for each one. I wouldn't create a new namespace for each one. I would only have one namespace called my Revit add-in, and then I would have several classes underneath. So the namespace is a collection of classes, and you have to name it in a way that is professional, clear, and easy to understand. The next thing we have is the transaction attribute. Now, in C# and in Revit, you need to initiate a transaction for Revit to read the command. If you don't have a transaction initiated, even if you write the code for the plugin, Revit doesn't know that this is something that needs to kind of start on. When you launch Revit, the transaction mode tells Revit that initiate this add-in. The transaction mode in this instance is read-only, which means I'm not trying to do anything to Revit. I'm not trying to create an element. I'm only trying to extract data from Revit. So I just want to extract data from a Revit environment and maybe visualize that data or export that data. If I wanted to make something, like if I wanted to make an add-in that would maybe create a wall or add some parameters, I wouldn't have my transaction mode as read-only. The next thing is the public class. So in C Sharp, you kind of always have to declare things. In Python, you'd probably just call your variable or your class name collect windows, and then you start working on it. But in C Sharp, you have to declare that this is a class. So if you think about Python, if you want to say variable x equals to 12, you would just say x equals to 12. But in C Sharp, you have to say var, which is the short form for variable, x equal to 12. So you always have to declare things. That's the main difference with C Sharp. And you see it throughout these codes that everything that you need to create has to be declared first. You have to declare what kind of variable it is first. Now, public means that it is not private, which if you've not learned about object-oriented programming in the terms of what's the public and what's private, that will need to be its own video. But for those of you who have done some coding, this just it means that it's going to be accessible publicly. Now, collect windows is the name of the class. This is something that I define. This is something that you define. You can call it whatever you want, but this is what's going to show up when there is an undo command in Revit. So when you undo, you would see undo collect windows, so to speak. So that's why the name of the class has to also be professional and clear. And of course, there's no spaces in coding. You always have to have it as camel case or capitalizing each word so that it can be read by the compiler. Now, iExternal command is what makes Revit add-ins. There are two types of interfaces that make Revit plugins. There's the iExternal command and the iExternal application. The main difference between the iExternal command and the iExternal application is that the external command is going to show up in Revit under your Add-ins tab under External Tools. So here is where you would have all of the iExternal commands listed. But if you have it as an iExternal application, Revit will create its own tab for it. So if you have any add-in like droots or PyRevit, you would notice it has its own tab, and that's because it's an iExternal application. So that's the main difference. And the one you choose depends on if you're trying to make just one or two commands for a project or a team, or if you're trying to make a suite of tools that needs to be collected under its own tab in Revit. The next thing is the public result execute. Now, this is when you call on the iExternal command, you have to identify the three different variables that make the command run. And that's the command data, the ref string, which is a message, and the element sets elements. These three are constants in every C# Revit API code. You would always have to declare them first before you start coding, because this is what provides the result. This is what calls on your transaction to execute the command and provide a result. Before you go in to start defining what you want your code to do, you have to tell the result what to do. You have to say if the result should report as succeeded or failed, because if you don't, then you have a chance of running into a loop error where the command just keeps running and doesn't exit. So you have to tell it that, okay, when it's done executing these sets of commands, return a result that's either succeeded, failed, and then the command can exit. Otherwise, your command is just running and your Revit is probably going to crash at that point. So let's get into the nitty-gritty of what the code actually says. This is one of the simpler programs that I've come across or written in the past, and I chose it because it's quite simple. C Sharp can be a bit intimidating when you look at it for the first time because you don't really know why there's so many words. What does this mean? What does this do? So I'm just going to go through each one and explain what it actually means in less technical terms. In subsequent videos, I will be a bit more technical to start going into the different variables and data types in C Sharp and what they do and how you can use them. I'm again trying to break that mental barrier of thinking that C Sharp coding for Revit is difficult. It can be challenging, but it's not more difficult than any other programming language that you would use to code for Revit. So the first thing you have to declare is the UI document, which is your command data application active UI document. Now this simply is the active Revit project. When you launch Revit as an application, you are actually accessing the Revit API's application.active-UI document. That's what makes Revit show up on your screen. Now, when you open a particular Revit project, so now you've launched Revit and you open, let's say, the sample architecture project, you are now accessing the documents of the Revit API. So that's why you go from the command data application active UI document, which is the whole Revit application itself, and then you go into the document, which is an open document. And that's where your code can access. So if you don't declare these two first, the code doesn't know the API is you accessing Revit's backend to make something that Revit doesn't do on its own. You're not making Revit do anything it can't already do because you're just accessing information in Revit's API, which is why in the first place you had to declare that you want to access Revit's database and Revit's UI. Okay, so in every C# Revit API code, you'll find that you're declaring the UI document and the document, because if you don't declare them, you can't access the active Revit project. Now, a filtered element collector is something used in the Revit API to retrieve elements. So this could be to retrieve maybe the number of windows, number of doors, retrieve a certain parameter of a family. The data type that you would use to do that is called a filtered element collector. Now, if this were Python, you would just say, okay, the name of my variable is collector, and I want it to collect everything that's in the active document, which is again your active Revit session. The document is the active Revit session. But because it's C#, you have to first declare it. You have to say, I am making a new filtered element collector called collector. And I want it to be a new filtered element collector that will access everything in my active Revit session. So the new means that it's been declared for the first time in your code. Again, the main difference between C# and any other language you might have used, the more modern languages, is that you have to really be specific and call out everything. So you would say filtered element collector, which is what you're trying to create, and then the name of the variable, which is why it's a different color, and then it's a new one because it's being created for the first time, and then what it is, which is a filtered element collector, and what is it accessing, which is the active Revit session, which is the doc. It can be a bit confusing, but just give it time to digest. Now, the next thing we want to do is access our windows, because this plugin is supposed to access only the windows in the active Revit session. The filtered element collector right now is passing through the entire Revit session. It's collecting basically everything in your active session. It's filtering through the whole session and collecting everything. So we want to drill down and add a filter to the filtered element collector, just so it's more specific to Windows. Now, this is called an element category filter. There are different types of filters you can apply. You can think of a filter in this sense as how you would use it in like maybe Google or SharePoint or OneDrive, where you're trying to search for a document and you apply a filter and it has to drill down to the specific document that you want. So it's kind of the same. We first create a collector to collect everything in the active Revit session. And now we're adding a filter to collect only windows. So because it's C#, again, you have to declare that I am making an elements category filter. If this were Python, you would just say filter is equal to new element category filter without the new, obviously, and then you would just go straight to the windows. But because it's C#, you always have to declare what kind of variable you are making first. So it's an element category filter. All of these you can access on the Revit API docs to know, okay, which one should I be choosing? Is it filtered element collector? Is it element category filter? The Revit API docs gives you that information. I will cover that in subsequent videos, so please subscribe if you want to see what that's like. The element category filter makes a new filter. Now, this is the name of the variable. Now, we could have called this anything. We could have called this Victoria, but again, we're trying to be professional. We're trying to be clear. And with code, it's important to remember that you might not be the only one working on the code down the line. So always name it in clear terms in ways that people can remember. Now it's a new element category filter because it's happening for the first time. And we want to access a built-in category for Revit. So Revit already has its built-in categories. That's your windows, doors. When you go into a Revit environment and you access the categories, now all of these are default categories in Revit, and you can access them through the API. And that's what it means when it says you're accessing a built-in category. In this case, it's the Windows. It's called OST Windows because that's how it's named in the Revit API. If I were to write this code from scratch and I take out OST Windows, as soon as I type in built-in category and I put the dot next to it because I want to call on that method, I am going to have a list of built-in categories I can access, and you can see that it's quite a bunch, right? And that's just how it's named. I would recommend, if this is your first ever video you're coming across on coding, that you should learn about object-oriented programming, what variables are, what methods are, and that will help you understand better what I'm explaining in this video. So I'm going to choose Windows again, and my code is back to working as usual. So the last thing we want to do is to apply this filter to this collector. Now, remember that we declared a new collector and we just made it to collect everything in the active Revit session. And then we created a new filter that only filters for Windows. But we've not actually applied this filter to the active Revit session collector. We've not actually told this collector that it needs to be filtered with this filter. So that's what this is. And because you're collecting windows, you're going to be collecting a list. That is the kind of data type that you're getting. So again, because it's C#, you need to declare it's a list. Now there's list and there's iList, and the difference is kind of in semantics, but also in function. I'm going to do a video where I go into the different data types subsequently, just so that this one isn't too complicated. And it's an element kind of list. It's a collection of elements. It's an iList element and it's called Windows. So again, when you see the blue kind of syntax, that is the actual name of the variable. Everything that comes before is you declaring the variable. The next thing is to apply this filter on this collector. So your new list is going to be this collector, but you're applying a method that wherever this filter passes, where passes, and where the element is not element type, there's the element which could be a cathedral window, an arch window, an awning window, a pivot window, a casement window, whatever that element could be. But then there's the element type, which is window. And in the Revit API, when it's collecting data, it's reading both the element, the actual element, but also the element type. So we don't want the element type. We want the element. We want the casement or awning or whatever kind of window it is. We don't want it reporting for windows, right? Again, it gets clearer when we go into the API docs, but if you've been coding for a while, I think you get what I'm trying to say. Now, where element is not element type, two elements, which is what makes it write the list. So it collects everything from the active Revit session. Wherever this filter, which is this filter that passes for Windows, wherever it passes, wherever the element is not an element type, add it to a collection of elements, print that out in this list. And that's all. That's all the code that's required to collect all the windows and then put them onto a list. Now, how do we see this data? So it's done in the background, but we don't actually see anything. The only way to do that in a Revit API C# code is to use a task dialog. And this is a pop-up window that shows in Revit. So you would say task dialog.show, which means I'm calling on the method show on my task dialog. I want it to show up. And the rules for that, if you highlight any code in C#, you would actually see the rules for how you should structure that code, like the rules for what it accepts, what data types it's looking for. Think of it like Dynamo, where you have to plug in something to a certain node for it to actually work. It's the same thing here. For you to actually see your results of the task dialog, it's expecting you to provide certain bits of information. And whenever you're working in Visual Studio and you highlight over anything, it tells you what it's looking for. So let's just test that through everything I've gone through today. If you highlight over filtered element collector, it's telling you that it's referencing the class Autodesk Revit database, and it's a filtered element collector, and this is what it does. If you highlight over element category filter, it's telling you where it's referencing, and this is what it does. And if you come here, it's telling you that it wants a built-in category and then the name of the category. So this is how Visual Studio sort of helps you write your code. Even if you don't know exactly what this code is supposed to do, when you hover over it, it tells you exactly what it's expecting. So a task dialog is expecting a string, and this string is going to be the title. So you know when you see a Revit dialog pop up, there needs to be a text at the top that says this is the title. And then you need to say like what is the instruction, what is it trying to do. So you're using the string format, which is how in C# you would convert different data types into a string. So whether that's a number, an integer, or whatever it is, you can convert that into a string. It's almost like string interpolation in, say, JavaScript or any other language, but here it's just string.format, and you're saying, give me a count of windows, and that's this 0 index here. So anything that is the actual count of windows is going to show up in 0. X number of windows counted. So anything that is going to be counted here is going to show up as 0, and that's the number of windows counted that will be displayed. And I already explained that you always have to give it a result command, otherwise your command doesn't know when to stop running. I've covered a lot of complex things today if this is your first time coming across code. If you're more experienced, I think you kind of understand what I'm saying, and I hope you're now able to delve into C# a bit better. So to round up, I'm just going to show you, okay, now you've written your code, how do you actually get it to run in Revit? For that to happen, you need what is called an add-in manifest file. To create that, you would right click on your project and say add and new item. And under new item, you would pick application manifest file and give it a name. In this case, the name is collectwindows.addin. And the application manifest file is a default kind of template that is provided by Autodesk. So if you go on the Autodesk Developer Network or the Autodesk website, you would see a text file that actually gives you all of these. It is the default requirement for when you want Revit to recognize an add-in. So all you have to do is fill in the values in between. So the first one is the name of the project you're accessing, and then the name of the assembly. So when you compile this project, it's going to be a DLL file. It always needs a unique GUID. Similar to Revit Elements having GUIDs, your Revit plugin also needs a GUID. But to create one, you only have to go to the Tools menu of Visual Studio and say Create GUID, and it gives you a unique ID, and that's all you need. This ID is not something kind of spectacular. It's really just a unique ID for your add-in, and so Visual Studio is able to generate that for you. The next thing is a class name. If you remember at the beginning, I said that you wouldn't have to make a new project every single time you want to make an add-in. You can have up to 20 or as many as you want under one add-in. The only way your compiler knows which of these add-ins am I trying to compile is what you specify here as the full class name. So the class name isn't just collect windows, it's first Revit add-in dot collect windows. That's the name of the class that it's trying to compile. The text is what displays when you launch Revit. This is what you will see as the name of the add-in. And you have to give a brief description just so that if someone has a bug, or if someone launches Revit for the first time, then they see a description of what your adding is. The vendor ID is who created this, and this shows up when it crashes. It says contact XYZ vendor. This is the information they provided to us. So I'm Victoria, I'm the BIM mentor. I could put my website here so that when it crashes, the user sees a website that they need to send an email to or something. And the visibility mode is not visible when there's no active document. What this means is that when you launch Revit, if there isn't an active document, again, remember that there is the Revit application, but then there's the active Revit session, which is the document. if I close out of all these documents, do I still want this add-in to show up? Or am I content to just say, when there's no active document, don't show the add-in? Like I don't want to see the add-in up here if there's nothing open. It only shows up when there's something open. That's what that means. So finally, we're going to actually compile this code now, and I'll show you what it looks like when it's compiled and launched in Revit. To do that, we will simply just go to press start and it starts to compile, and you would copy the compiled files into your Revit program data directory. So really your Revit adding is a collection of files that you've compiled from C# or wherever you created them. And once you have those files in the right folder, it's going to launch as a plugin. So if I double click on the properties section of my add-in, I can also tell it where I want it to copy the files to. So instead of copying it to some random folder, I can actually direct it to the add-in folder in Revit. And so every time I build the command, it's just going to go straight to that folder. I need to tell it to copy to a target directory. And this is usually your computer's app data folder under the add-ins and in the right version. So my software is Revit 2023, so I'm going to change this to Revit 2023. And if I say start, which means I want to compile the code, you can see it's running, it's ready, and it's telling me that the build succeeded.